Okay, so now we are going to get into understanding the volume of a cube. So this is actually going to be activity 3-2 in your Springboard books. So we're going to go ahead and we're going to get started. So first of all, if we're thinking about a cube is a 3-dimensional figure, meaning that it takes up space. Okay, it pops. We'll say that it pops. And it is like 6 squares. So that's a square, that's a square, that's a square. Okay, so it's 6 squares. So when we're looking at its edges, each edge is equal. Okay, so each value here, like that's 2, that's 2. So when I calculate the volume, the formula for volume is length, so that's your length, times width, that's your width, that's how wide it is, times height. Right there's how high it is. All right, so now if I know that length is 2, and width is 2, and height is 2, I could say that volume is one of those values. So it's one of those measurements. So we'll say like the measurement of an edge, just to keep it simple, to the 3rd power. So my volume equals 2 times 2, which is 4, times 2, which is 8. So 8, and here it's just units, because that's what it gives me right there, cubed. Okay? So I want you right now to talk to your group about how do you calculate volume. So I want you to talk to group, how do you calculate volume? Then I want you to hit play and come back to this. Okay, great. So now we're going to go ahead and we're going to practice this. I want you to look at page 39 under the Try These A. It says, complete this table, show the volume of each cube in exponential form. So right there, that's an exponent. So in exponential form and in cubic feet. So we're going to call this here, we're going to give these other ones a couple names. This is what we call expanded form. And this is what we call standard. Then this one right here would be exponential. All right, I'm going to jump down. You can see what they did in that first one. Take a look at that. I'm going to jump down and I'm going to do kind of the most difficult one because the number is the largest. So if I have a cube and each edge is 9 feet, then my formula is going to be 9 times 9 times 9. I could write that and see how that's an expanded long number. I could write that as 9 to the power of 3, or 9 cubed. So then when I go in and I calculate my volume, I could calculate that by hand, or you can pull up what I call Desmos. So take a look at my browser and you can type in desmos.com/scientific. And here you can do a couple things. You can do 9 times 9 times 9, and it gives you that answer right there. Or you could do 9 and then see this little like a to the b power, so 9 to the power of 3. Either way, your standard form, or just the number value, would be 729. So over here I can write 729 feet cubed because I have to remember my units. So right now I want you to hit pause and I want you to work with your group to do the rest of these numbers. Okay, fill in the rest of the boxes to find the volume of cubes with those different side lengths. And then I want you to hit play and check your answer. Okay, so you should have these numbers right here, go ahead and check your charts. If you are confused or have a question, please raise your hand and we'll come over. We are more than happy to help. So now I want us to jump into try these B. And it says simplify each expression. So when you simplify it, it gives it to you in a couple of different forms. So I'm gonna do letter C and letter D, and then you're gonna do A and B. So here for letter C, 11 to the third power, or 11 cubed, is 11 times 11 times 11. And then when I jump into Desmos and I do that, so I make sure I have a new line, 11 to the power of 3, I get 1,331, which is the exact same thing if I did 11 times 11 times 11. Okay, so for letter C, I would get 1,331. Okay, for letter D, 1.5 times 1.5 times 1.5, I can rewrite as 1.5 cubed, or 1.5 to the power of 3. And again, when I put that into my calculator, to the power of 3, I get 3 and 375 thousandths. That's the exact same thing that I would get if I did 1.5 times 1.5 times 1.5. Okay? So that's how we calculate the volume of those. I want you to go ahead right now and I want you to try to do A and B on your own. I want you to write it in either, if it's given in exponential, I want you to write it in expanded form, and then give the standard form as well. All right, so you should have these answers up here for your A and B. So now I want to point out on your note sheet. So here, this is everything we talked about. So that side, so the volume equals like the side length right there, or you can call it the edge to the power of 3. And you could say that as to the power of 3, or because it has a special relationship with this figure right here, and with this cube, you could say side cubed. Either way is correct. Right now, I want you to just, if there's anything that you don't understand from these notes, I want you to raise your hand and ask. We're about to move into cube roots, but you have to understand cubes before we get into their roots. All right, great. So now we're going to jump into understanding the cube root. Okay, so when I have a cube, what that tells me is that I'm given the volume. So if I have this cube right here, and its volume, it tells me, is 125 feet cubed. What I don't know right now is I don't know, like, what is this side length, or any side length? Like, what is this side length right there? Okay, so I don't know what that side or what that edge length measures, and that's what I want to find out. So if volume is length times width times height, then volume is a number times that number times that number. Okay, so I just have to figure out, like, what is that number? So 125 equals something times itself 3 times. So when I take the cubic root of this, I would know that 5 times 5 times 5 equals 125. So I would say the volume equals 5 cubed, or I would say 125 equals 5 cubed. So my cube root, the actual answer to this question, my cube root is 5. Okay, my cube root is 5. So if it is asking me what is the cube root, I would say that the cube root here is 5, because that equals the side or the edge, however you want to define that. That equals like the measurement there, which is the same as the measurement there, which is the same as the measurement there, because it's a cube and all the sides are equilateral or equal. All right, so let's jump into this. Here, if you are given the volume, so you have your little cubes, and on page 39, you're given the volume. You want to figure out what is the length of the edge in units. So what times itself 3 times would give you, we're going to start here with 64. So if I had that right there with 64, I want to know what times itself 3 times equals 64. It's going to be a whole number. I want you to see if you can try to guess it. If you guessed 4, you are correct, because 4 times 4 times 4. So here, 4 times 4 is 16. 16 times 4 gives me 64, because I just bring that one down. Okay, I want you to go ahead and try to do these other 3, then hit pause, and then you can come back and you can check your answers. All right, great. So if you had 1 for this first one, you are correct, because 1 times 1 times 1 is 1. If you had 2 for the second one, you are correct, because 2 times 2 is 4 times 2 equals 8. And for the third one, if you had 3, you are correct, because 3 times 3 is 9 times 3 is 27. All right, excellent. So now I want to show you now I want to show you kind of how this works out using a calculator. So here, if we're given the side length and we want to know the volume of the booth, in our calculators, we would take that side length, give yourself a new line, but take that side length, which was 2, and we would do it to the power of 3. So in this case here, if my side length is 2, the volume of my booth, or the volume, is 8. Now, if we wanted to work backwards, we would do what we call the cubic root. So if you remember from yesterday, a square root looks just like this, okay? And that just finds the square of a number, okay? Now, a cubic root, take that same radical symbol, but this time we call what we call an index of 3. And that 3 tells me that it's a number times itself 3 times. So a number times that same number times that same number equals the volume, or whatever this is. So in this case here, if it tells us that the volume is 27, I'm going to put 27 in there, and I'm going to figure out what times itself 3 times gives me 27. I'm going to go into my calculator and see this little symbol right there where it has n. So instead of saying n, I'm going to put in a 3, and then I'm going to put in 27. And it tells me that the side length is 3. You should memorize up to 5. So if that's 3, what do you think the 64 is? Go back to kind of where we were right here. So if that's 3, my 64 side length is 4. Okay. I want you to do these 3 on your own, and then I want you to push play. So pause right now. I want you to push play and check. All right, so now these should be your answers right here. You could use the calculator to do them. I put these into the calculator. For here, 10, I recognize that there's 1, 2, 3 zeros, so I knew that my base was 10. Okay, so right now, we just talked about cubing and squaring. You have the notes for today. I want you to mark these notes with anything that you need to remember, and then I want you to summarize them in your own words. So you can summarize in English, you can summarize in Spanish, whichever your preference is, to summarize these notes and talk about what you learned today. So real quick, now that I'm thinking about it, some good sentence starters would be, today I learned. Okay, and again, that can be in English or in Spanish. And then some vocabulary that you should use is cube roots and volume. Okay, so those are the vocabulary terms that you should use. But then you're going to write your own summary. So after this, you're going to write your own summary in your own words. Please, please, please raise your hand if you have any questions or don't understand something.